Hello everybody, welcome to 10th ICSE Learning Mathematics videos. Today we'll be discussing about heights and distances, and in that we'll be covering the practice problems related to heights and distances. So let's start. You can see here we have the first example. Before proceeding further, I would like to tell you, if you want to know in detail the concept about heights and distances, like what is angle of elevation, what is angle of depression, what is vertical height, what is horizontal height, what is line of sight, and the steps we need to follow in order to solve this question, then you can visit our website or you can view our YouTube channel. In that, there is a video with name Heights and Distances, Concept and Explanation. So in that I have explained everything in detail. In this video we'll be concentrating on solving the examples. So let's start. Here is the first example, that is the length of a shadow of a vertical tower is √3 times its height. We need to find the angle of elevation of the sun. So in order to solve this question, we need to follow these steps. So the first step is to draw a correct diagram and label it. This step is very important, because if you are not able to make the diagram correctly, then the whole question will be wrong, because you'll be doing calculation based on that wrong diagram. So making the correct diagram will solve 50 to 60% of the problem. After that, it's just the calculations and finding the suitable trigonometric ratio and substituting the value and doing the calculations. So the major and the most important step is the step 1. That means we need to draw the diagram correctly and label it. For that, we need to refer to the question so that we can draw the diagram. So it is given that the length of a shadow is always horizontal, of a vertical tower. So first of all, we are going to draw the vertical tower. This is the vertical tower and I am naming it as AB, and let this be the sun. So now we need to draw the shadow. Now I am drawing the shadow of this vertical star from the foot of the tower, that is B, and let this be point C. This BC represents the shadow of the vertical tower. Now in order to find the angle of elevation, we need to join AC and let theta be the angle of elevation of the sun. So this angle ACB is theta. This is the angle of elevation of the sun. Now, in order to solve this question, we need to do some assumptions. So we will be considering the height of the tower to be h meter. So that means AB is equals to h meter. In case no unit is given, so by default you can take the unit for the distance as meter. So here AB is equals to h meter, which I'm writing here. Now, as it is given in the question that the length of the shadow of a vertical tower is √3 times its height. So the length of the shadow is BC and it is √3 times the height of the vertical tower, which is AB. And if we substitute the value of AB, we get here as √3 times h meter. So now if we consider this triangle ABC, we have AB as h meter and we have BC as √3 h meter. Now the second step is to apply the suitable trigonometric ratios and substitute the given values. So now in order to choose which trigonometrical ratio I will be using, I have to see what I have with me, what is given. So here you can see that AB is given as h meter and BC is given as √3 h meter. Now considering this angle theta, which is the angle of elevation of the sun, this AB becomes the perpendicular, or you can say opposite, whereas BC becomes the base, or what we have adjacent. So if we consider perpendicular and base, so the trigonometrical ratio which relates perpendicular to base is the tan theta, because tan theta is equals to perpendicular upon base. So in the second step, I would be using tan theta and substituting the value of perpendicular and base. So in this triangle ABC, tan theta is equal to perpendicular upon base. So the perpendicular is given by AB and the base is given by BC. So here, if I substitute the value of perpendicular AB, it is given as h meter and the base is given as root 3 h meter. So this h and h will get cancelled out and we are left with tan theta is equal to 1 upon root 3. Now if we consider the value of thetas in terms of tan, then tan theta is equal to 1 upon root 3. So I'm going to write here tan theta is equal to tan 30 because tan 30 degree is equal to 1 upon root 3. So this implies that theta is equal to 30 degrees, which is the required answer. So the angle of elevation of the sun is 30 degrees. Now the next question. The angle of elevation of a top of a tower at a distance of 120 meter from its base foot on the horizontal plane is found to be 30 degree. Find the height of the tower. So the first step is to draw a correct diagram and label it. So now we need to find the height of the tower. So for that we need to draw the tower. Here is the tower I am representing is at AB. A represents the top of the tower and B represents the bottom or the foot of the tower. Now as it is mentioned in the question that we need to find the angle of elevation from a point 120 meter from the base foot of the horizontal plane. So this is the foot or the bottom of the tower and let us consider this point C at a distance 120 meters from the base of the tower. So I'm going to join BC. So BC is equals to 120 meter and it is given that from this point to the top of the tower the angle of elevation is 30 degree. For that we need to join AC. So this angle is given as 30 degree. So angle ACB is equal to 30 degree. Now in order to find the height of the tower we need to do one assumption that we need to consider the height of the tower as h meters. So now I'm going to write what is given. We will consider that the height of the tower is equal to h meter. That means AB is equal to h meters and it is given that BC is equals to 120 meters. Why I am writing this? Because this will help me to select the suitable trigonometrical ratio to find the answer as per the step 2. So on considering this angle 30 degree, AB becomes the perpendicular and BC becomes the base, and the trigonometrical ratio which relates perpendicular and base is the tan theta, because tan theta is equals to perpendicular upon base or opposite upon adjacent. So in this triangle ABC I'm going to write tan theta is equals to perpendicular upon base and then I'm going to substitute the value to get the height of the tower. So now in this triangle ABC, tan theta is equal to perpendicular upon base, that is equals to AB upon BC. In this question theta is given as 30 degree, so I'm going to write tan 30 degree is equal to AB upon BC. AB is equal to h meters and BC is equals to 120 meters. So tan theta is equal to h meter upon 120 meter. As we know that the value of tan theta is 1 upon root 3, so that is equals to h upon 120. So now on cross multiplying we will get root 3h is equal to 120 and h will be equal to 120 upon root 3. Now as per this step 3, that if the square root is in the denominator we need to rationalize. So I'm going to rationalize this root 3. So I'm going to multiply root 3 with the numerator as well as with the denominator. So the numerator will become 120 root 3 upon root 3 into root 3 will give me 3. So h will be equal to 120 root 3 upon 3. Now the value of h is 120 root 3 upon 3. Now as per the step 4, we need to write the final answer up to 3 decimal places. I would recommend, if nothing is given, write the answer up to 3 decimal places. For that, we need to substitute the value of root 3 up to 3 decimal places. So the value of root 3 will be 1.732. So on substituting the value of root 3, it is 120 into 1.732 divided by 3. So we will get 207.84 in the numerator on multiplying 120 into 1.732 divided by 3. So if you divide, you will get the answer as 69.28 meters. So automatically this answer has come to up to 2 decimal places. So we can leave the answer up to 2 decimal places. But in case you would have taken root 3 up to 2 decimal places, so you would have get the answer up to 1 decimal places. So I would recommend that always take the value of root up to 3 decimal places in order to get the exact and the accurate answer. So the height of the tower is 69.28 meters. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Have a great day.